So good morning, everyone. Welcome to day 2 of J Prime. And it's my pleasure to introduce you Ram Lakshmani, who is here for second year, I think.
Yes.
Yeah. So stage is yours.
Okay, thank you. Okay, so hello friends. Good morning, everyone. Welcome to the day 2 of J Prime. So friends, before I get started, I just wanted to thank all the J Prime organizers, right? So they are doing a really wonderful job to the Java community, right? They all have a daytime job, but they're organizing such a wonderful conference. So maybe we'll just start our conversation with giving applause to all the organizers. Right? Like Dimitri, Martin, Yvonne, Alexander, everyone is doing a wonderful job, right? Okay. Okay. So let's get started. First of all, I'm surprised by the turnout for the garbage talk, right? I didn't expect this much audience to come. Thank you, everyone. Okay. So friends, what is garbage? Does anyone want to say what is garbage? Huh? Huh? Me too. Okay. Does anyone want to say what is garbage? Yeah, something that we don't need anymore, right? Okay. See, friends, I also have a definition for garbage, but I'm not going to say now. I'm going to say at the end of my talk. Okay. But let's find what makes garbage actually within the JVM memory, right? See, friends, all our applications have a memory, right? We set XMX. We set it to 2 GB, 6 GB, 10 GB. Even I've seen some JVMs which is running on a 1 terabyte or 1.5 terabyte spaces. So even when you set like that, still it is a finite space, right? So when a new request comes to our application, it's going to create tons and tons of objects, right? We as a development community, no one today, at least most of us, don't care about writing a memory efficient code, right? There is a book I will show you at the end where it says it complains and criticizes how as a development community we are getting sloppy and how we are creating so much objects in memory. And this book was written by Microsoft co-founder Paul Allen, right? Okay, so friends, just think about it. Take a second. Let's say a customer sign-on request comes to our application. Think we are creating thousands of objects to service a simple vanilla sign-on request. Think about it. What are the objects we are creating? When a new request comes, it's processed by an application server, a Tomcat server. So Tomcat server creates its own set of objects, right? There is a servlet request object, servlet response object, HTTP filter, session, and then it goes through the Spring Boot framework or a Spring framework. That creates its own set of context dependency objects, and then it creates a manager object, it creates a data access object, then there's a connection pool, from there we check out the connection, and then we make a backend call, it makes a result set. All of them are objects. We are creating tons of objects. So now I created all these objects. And now based on that, I service the request. Okay, now the request is, we can say the customer is authenticated or not authenticated. Now the request goes away. Now, what's going to happen to these objects that we created? These objects doesn't have any more reference, and these has to be removed from memory so that the memory frees up to process new incoming requests. So this is called as garbage. There is objects which doesn't have any more reference. It has to be removed from memory. So friends, how are objects garbage collected? How is this garbage removed from memory? Like 3-4 decades back, if you are a developer, back in three decades back before Java was there, if you are a developer, you need to be writing code to remove every object that you are creating. Say today as a developer, we only say new customer object, new account object, new array list, new hash map. That's what we say. We don't remove those objects. But if you are back in those days, before 3 decades back, if you are a developer, you need to be removing those objects. You need to write the code to remove the objects. Think about, friends, our business applications are very complex. There's multiple methods, multiple workflows. Even in one method, if I don't deallocate object, those objects will start to build in memory. So memory leak was very pervasive back in those days. Like I was talking with one fellow speaker, Ken, he was saying back in those days, once they write a program, it's guaranteed it's going to have a memory leak. So, it was getting frustration. So when Java came into existence in 1995, Java told to the development community, hello developers, you don't worry about doing this garbage collection. You don't have to write a code to delete the objects. I will take care of doing as a runtime environment. I will do it. Developers really liked it because we can focus on the business logic. Management liked it because less out of memory error, which is a wonderful thing. But friends, even before Java, in 1950s, there was a language called Lisp. That was the first language to have this automatic garbage collection. Once Java came, Java really championed it. But since then, after 1995, once Java came, all the modern programming languages, let it be .NET, Python, Go, all of them has this automatic garbage collection, which is a very nice thing. I am a supporter of that, which is a very nice thing. But this automatic garbage collection has two primary side effects. What are those two primary side effects? The first one is it stops your application. It pauses your garbage. When garbage collection runs, it stops your JVM so that it can identify what are the active objects. So how does the JVM identify these are active objects? So what does it do? It has to go to an object. It has to see who is referencing that object. Now it has to go to that reference object to see who is referencing that. So it has to walk through those object hierarchy to see what is having any active reference or not active reference. Our application is creating millions of objects. So you have to walk through all these objects because it has to pause, because if it doesn't have to pause, our application threads is going to modify the pointers of the object, so it will pause. So the first side effect what it does is it stops our application. If any one of your customers says, oh, your application was running fine, but for a few seconds it didn't respond. Once again it started to respond, it's very likely the garbage collection is running in the background. So this is the first side effect. Friends, the second side effect is it consumes enormous amount of CPU cycles, because look at this, it has to constantly keep scanning millions of objects in memory to see which is acting active reference, inactive reference. To do that, it is going to consume a lot of CPU cycles. Say if your application is consuming 60% CPU, probably 40% CPU is consumed by garbage collection. So these are two primary side effects. I'm going to be showing you a real world case study right now, right? So this is a GC performance problem faced by a very major automobile manufacturer. Is one of the largest automobile manufacturer. So this problem happened in their one of the critical Java application. So let's look into that, what it was. So I will get to how to find all these numbers and metrics for your application. We will discuss that. See, look at this. This application, this is the pause time of that application. Let me zoom in. Look at this. There is one garbage collection event running, and it is stopping for 12.8 seconds. That is, when this garbage collection runs, it is stopping the JVM for 12.8 seconds. And look at the another event. It is stopping for 11.4 seconds. This is all full garbage collection. It's taking a long time, but here there is a young garbage collection. Look at this. This is all taking like a 700 milliseconds, 800 milliseconds, 900. It's taking that. It is continuously pausing. So when this JVM is pausing, what's going to happen? If a customer request comes, he's not going to get response back. He's not going to get response, right? Because this is stopping the JVM. When this JVM was tuned, look at this, when this was tuned, so this is that, this was their baseline response time, the customer facing response time. This is nothing to do with the garbage collection. A customer facing response time was 1.88 seconds. When they do the GC setting tuning, that is GC setting tuning means what? Changing some arguments in your JVM. When they did it, look at their response time. It dropped to 0.95 seconds. That is 50% reduction in the response time. Think about it. This is achieved without a single line of code change. See friends, we all have been working in the industry for quite some time. Take a pause right now. Let you be the garbage collector. Take a pause. Now look back in your career. How many times were you able to improve your application's response time? You have to improve overall application response time. How many times you have done? Maybe we might have done few times. That too by, maybe we would have refactored some backend SQL calls, or we might have made some concurrent parallel threads. With those kind of things, we might have improved the response time of few key transactions, nothing of the system wide. And that too, when you have to refactor the code. You have to do some parallelization. You have to move to a different infrastructure. Whereas with this garbage collection, the most powerful thing is, it's a zero risk. That is, you're not changing any code. 0 lines of code is touched. Just the JVM arguments are tweaked. When you tweak, you are going to see this remarkable improvement. Because the garbage collection pause time is going to come down. When garbage collection pause time comes down, automatically your response time is going to get better. Right? Okay. I want to show you another metric here. See friends, here for this, in the same report, in this automobile manufacturer, there is this metric called GC throughput percentage. It's reported as 95.5%. So what is GC throughput percentage? It is one of the key performance metric you need to study when it comes to garbage collection tuning. So what is throughput means? GC throughput means. Let's look into this. Friends, when someone says is GC throughput is 96%, what it means is this application is spending 96% of its time in processing the customer transactions and remaining 4% of time in processing the GC activity. That's what it means. It's spending 96% of time in processing the customer activity and 4% of time in processing the GC activity. Let's look at what it means in terms of absolute time, right? Look at this, one day as 1,440 minutes, right? Because 24 hours multiplied by 60 minutes. That means 4% is spending in garbage collection means 57.6 minutes per JVM is doing garbage collection per day. Every day this JVM, this automobile manufacturer's JVM, is doing garbage collection for 1 hour. For that 1 hour, it will not process any customer transaction. I want to give you this scenario. That means if garbage collection, effectively JVM is sleeping actually. Think about what I'm going to say now. Tomorrow you go to work, right? Your employer is paying you to do a work. Now I go to work and then I sleep there for 1 hour in office. What will happen? Most likely we will lose our job. And that too I'm doing it every day. Every day I'm going and I'm sleeping for 1 hour. What will happen? I'm going to be losing my job. But friends, that's what all our JVMs are doing today. Maybe this is an exaggerated case, 1 hour, but your JVMs are also sleeping. Maybe it is sleeping for 10 minutes, 20 minutes, but it is sleeping. But sad story is we don't even know it is sleeping. I will teach you how you are going to find how much time your JVMs are sleeping. So response time improvement is one thing you are going to achieve. Second thing is you are going to improve, you are going to reduce your computing cost. How? Look at this. Here, if it is 96% throughput, let's just make here. Let's say here is a table. Let's say it's a 96% throughput. It means for 1 day, your JVM is sleeping for 57.6 minutes. That means for 1 year, it is sleeping for 350 hours. I think it is 1 week. Your JVM is going on holiday. Bye. It's taking a vacation. But friends, if it's going on a vacation, still I need to be paying for my cloud provider. My cloud provider is not going to stop billing me. He's going to bill me on an hourly basis. Think about, let's say you are an organization who is running with 1,000 EC2 instances. And if this 1,000 EC2, each EC2 instance is taking a break for 350 hours per year, look at the cost, $200,000 US. You are wasting that to assuming I'm using a 32 gig Red Hat Linux machine. And if this is the cost of a 32 gig Red Hat Linux machine in AWS cloud. If I'm going to be running I'm a very large financial institution, I'm running on a 100,000 EC2 instance, look at the cost, $20 million we are wasting. Friends, it's not me bringing up all these numbers. I have been saying this always, but look at this. This is a tweet from one of India's largest SaaS company CEO. That company is called Zogo. Look at this. He is saying there are some languages which doesn't do this automatic garbage collection, like this Objective-C Swift from Apple. He says that one decision saves at least $5 billion per year. But of course, they are going to inherit the memory leak consequence. Now, in this session, I'm going to be teaching you how much time your JVM is sleeping and how you can optimize. So friends, when you're going to optimize, your response time is going to get better. Your computing cost is going to get better. And third, your CPU consumption also goes down. Look at this. This is a real case study. Uber, one of the world's largest car ride-sharing app, their computing cost was ballooning. And they had to refactor, they had to modify the GC settings, and they were able to reduce the 70K core CPU consumption, and they were able to reduce their computing cost by several millions of dollars, right? So these are all the wonderful things you can achieve by doing GC tuning, that too without making a single line of code change. Isn't it very wonderful? Yes? Okay. So let's move. With GC tuning, we can also predict your memory outages, but I'm not going to be talking now because of the lack of time. I'll be skipping. Okay. So friends, let's dive a little bit into details, which is going to facilitate you to do garbage collection tuning. How many garbage collection algorithms are there in Java 11 onwards? Anyone want to take a guess? How many garbage GC algorithms are there in JVM, OpenJDK? 4. That's good. Close. Actually, friends, there are 7 GC algorithms: serial, parallel, CMS, G1, Shenandoah, ZGC, and Epsilon. This is just in OpenJDK. If you go for IBM JVM or a specialized JVM like OpenJ9 or Azul, those JVMs have their own set of GC algorithms, right? And friends, here is an interesting question. How many GC and memory related JVM arguments are available? To JVM, how many GC and memory related arguments you can pass? Say for example, XMX is one argument, XMS is another argument. Like this, how many arguments you can pass to JVM? Just around GC and memory. Any guess? 6? 100? What? Okay. Guys, ready? You can pass 600 plus arguments just around GC and memory. So, it is overwhelming, right? See, okay. So, but friends, you are not alone. You're not alone. See, I do this for living. This GC tuning, I do this for living. I also don't know much. I hope my potential new company engagement, they don't see this. That's what I'm saying. I also don't know much. But I'm going to be sharing with you few simple techniques that I follow and using which we were able to make remarkable improvements. I'm going to be sharing all those techniques, what I've been learning over the years right now in this session. So you can take it and put it for work at your workplace. Okay. So let's keep going. Friends, when it comes to garbage collection tuning or in general any tuning, you need to understand what are the key performance indicators. See, there is this famous saying, you cannot optimize what you cannot measure. So if I want to optimize something, I need to know against what parameters I am measuring. So when it comes to GC tuning, there are few key performance indicators against which you will be conducting your measure, or against which you will be doing a testing. Let me share that. The first KPI is called as latency, or it's called as the average pause time. When a garbage collection event runs, it stops your JVM. So this metric tells how much time my JVM was stopping, right? This is what this metric tells. And then the second metric is the throughput, what we discussed just now. The throughput is basically a cumulative time over a 24 hours period, how much time my JVM is stopping for doing garbage collection and how much time it is spending on doing the customer activity, right? This is the second metric. The third metric is footprint. Friends, when I modify the GC settings, right, when I go from one GC algorithm to a different GC algorithm, to do garbage collection, JVM needs some memory. So when I switch my algorithm, my memory consumption can go high. And also when I switch my algorithms or change my settings, my CPU consumption may go high or CPU consumption may go down. So this, I want to measure what is my fluctuation with that. What is my footprint fluctuation? And friends, the final and the most important metric when it comes to tuning, or not in GC, in any performance exercises, what is my response time? What is my customer facing response time? This is the most, I can do anything internally, but what matters is when my transaction hits the customer, how much time it is taking, right? So these are the 4 KPIs against which we need to be doing the GC tuning exercise, okay? See friends, now let's talk about how am I going to source these metrics, from where I can get these metrics, okay? So friends, you can get these metrics by enabling the garbage collection log on the JVM. So you can enable it by passing this kind of an argument, right? If you're running on Java 8 or before, pass this argument and give a file path. So in this file, the GC log information will be returned. And if you're running on Java 9 and above, pass this argument. So GC will be returned here. Friends, when I say this, people ask me, oh, what is the overhead in enabling the garbage collection log? Friends, it is almost zero overhead, because generated by JVM, it just writes it to the disk. It's almost zero overhead. And here is a white paper we have published. You can take it and then you can look at it. See, when those APM tools and all they say, those tools and all are intrusive. They say sit within the JVM, and then they have significant overhead. Whereas this is very, very lightweight overhead. In fact, I have seen very large scale Java deployments where it's where one enterprise, they're running on a 300,000 JVMs. In all those 300,000 plus JVMs, they have enabled the GC logging because of the benefits they get by doing, there's so much benefits by looking at the GC logs. So how does a GC log look? This is how it looks. Full of numbers, right? You can look into this. You can open a text editor and then you can look into it also. But it's a little bit cumbersome and a little bit tedious to do. And friends, the problem is this GC logging is not standardized as well. This GC log format, it varies by who is your JVM vendor. Each vendor has their own set of format of GC log, and they have their own, and it also varies by what version of Java you are running and what algorithm you are using and what arguments you are passing. Based on the GC log format is going to vary. So today in the world there is like 80, 90 different formats of GC logs. So for example, this is how a GC log looks like of a G1 GC algorithm. If you're going to use concurrent mark and sweep algorithm, this is how it looks. If you're using IBM JVM, they are printing it in a structured XML format. If you're using a modern version of IBM JVM, it's a different XML format. Friends, this tuning exercise, whatever we do, is also applicable for Android, because Android is also running on a JVM. This is how Android GC log looks. So it is a lot of GC log and it keeps varying. So friends, here is some of the tools I would like to share. These are some of the tools available. You can use whichever the tool of your choice. I'm not going to say which is the best tool because my opinion is going to be biased. GCEC is the best tool. Because this is what my company makes also. Okay. But you don't believe, you don't have to take my words, you can use whichever the tool of your choice, right? Friends, now what I will do, let me show you how to use this tool, okay? So this tool is available online as well. You can go in here, you can sign in, upload your GC log and look at it, or this is also available as an on-prem. You can download it and install it on your local machine, and then also you can upload the log and see the results, okay? So once I enable the GC log, what I can do, I can come here and then I can upload my GC log file. Let me upload a sample GC log file. See, I'm uploading a GC log file. The internet connection is a little bit slow, but anyway, it processes it, and then you are going to see the result. See, once you upload it, that if there are any problems is found in your GC behavior, it's going to report it at the top with the warning sign, and then it also gives you the recommendations. What GC flag to pass, what to remove, what to increase, it gives those recommendations here, right? Okay, so friends, once I upload, here is I can see my heap behavior, how is my memory is behaving, and what is my time my application is stopping, pausing. I can see by clicking on this, I can see how much it's stopping. But friends, most important section what I look in the GC report, let me share, it is this KPI section. This KPI section, look at this, it's sharing what is my throughput, what is my CPU time because of garbage collection, how much time I'm spending on CPU cycles I'm consuming. What is my latency, how much time I'm pausing. So this is all the metrics, this is all the key performance metrics, right? The latency, the throughput, CPU time. This is all the metrics, okay? Once I have this, what I need to do, friend, this is the secret sauce. This is what I do for living. I'm going to sharing with you. Look, I have this kind of a spreadsheet, right? So here, I say, I put the, what is my current set of JVM arguments I have. I put it here. And then here I document what is my KPIs are. What is my average pause time? What is my max pause time? What is my GC throughput percentage? I document all of the KPIs here. And then I put the report URL. Now what I will do, I will change these arguments. I will change these JVM arguments. I will add an argument, I will remove argument, I will increase the value or decrease the value. Once I do, then I will keep documenting those values here, right? So maybe I will try to see whether I can find a real use case. Okay, it is loading. Okay, well, so what I do, I keep increasing the value, decreasing the value, and whatever gives me the best result, that's what I will pick up and go with it. So here is a real case study. Look at this. There is a real case study. Look, we start out like this. Okay, then we document these values. Okay, now I find, oh, this is the value, this is the one which is giving me the best performance result. This setting is giving me best performance result. Then I will go ahead with it. So now, how will I derive what are these values are? It is to a surprise. It will be most of the time, always it is a trial and error. Right? I change values, I increase, and then I see whether it works. Then I go, okay, then I say this is what the best setting is. Friends, I'm going to sharing with you some tips on how to come up with these values. I'm going to be sharing with you. But before that, yeah, so I'm going to be sharing with you how to come up with these values are. But otherwise, friends, it's a trial and error. That's what it is. There is no one in the world who can say, oh, to your application, set these GC settings. Your application is going to get several times better. Your pause time is going to go down. No one can say that. Everyone has to experiment it, and then only they can come up and tell what's going on. So this is what we do. So now what I'm going to be doing is I'm going to be sharing the remainder of my time I'm going to be sharing with you the tips which will help you to come up with this kind of a settings, how to go about coming up with these settings, right? Okay, so let's move forward. Okay, friend, this is the first recommendation, first tip I want to share with you. All of our Java applications are running for 5, 10, 15, 20 years. And all our applications have a set of these JVM arguments, right? Which we are very afraid to touch. Oh, it is there. Oh, okay. It is kind of a holy Bible. We cannot touch it, right? Right? Because we don't understand what it is, first of all. So we are afraid to touch. But friends, my first recommendation is get rid of everything. Get rid of all the arguments, right? Why I am saying that? Because see, look at this. The Java has been evolving. Starting from Java 8, the default GC algorithm is G1 GC. Before that, the default algorithm was parallel GC. So what I am seeing now, even if the application is running on Java 14 or something like that, they still to carry the parallel GC setting. That means they are carrying old algorithm settings for the new G1 GC algorithm. And they carry, and maybe your architect at that time, you might have configured the arguments for the traffic at that time. Your traffic has changed. Your number of JVMs has changed. Your business logic has changed. So all will have an impact. So what you had earlier is not applicable anymore. So get rid of it. Completely get rid of it and start the tuning from the scratch. That by itself can give you a good relief. See, friends, I do give this as a workshop as well. What you are seeing is a 1 hour condensed session, but I do give this as a workshop. One of the student who attended my workshop is called as Ryan Smith. So he, at that point, he used to work for a company called CloudBees. So CloudBees is the company which is became the Jenkins. Several of us use Jenkins, right? So he was the developer support engineer. So he attended this training program, and he started applying these tips in various deployments, in JVM deployments, and he started to see phenomenal success. And then he started sharing all these success in various developer conferences, and now he is more popular than me. But I'm okay. I'm happy for him. I'm really happy for him. So for next few slides, next 2-3 slides is from him. I asked his permission, and I'm going to be sharing what he is sharing in his conferences. Okay. So look at this. This is a Ryan Smith slide, who was one of the student of the workshop. He was just attendee like you. This is a JVM performance of an application. Look at its throughput. Throughput is 92%. That means this JVM is sleeping for 2 hours. And look at the pause time, 20 seconds. So these were all the arguments which was configured on the JVM. Ryan Smith, a good student, he followed the advice, he got rid of all of them. When he got all of them, look what had happened. He didn't have to do anything, he just got rid of things. Once he got rid of things, the throughput went from 92% to 99%. Right? See, friends, sometimes, I hope it is not the case in your organization, sometimes in your organization there may be some people, even if they don't contribute to success, even if they don't contribute to progress, if they just keep quiet, we can make a lot of good progress and make good improvement. But just because they are there, we wouldn't be able to progress effectively. These arguments are like that. But its JVM is very easy, arguments are very easy to get rid of it, so got rid of it. Okay. Okay. This is another slide from Ryan Smith. Look at this. This is a JVM pause times of a very big shipping company. Look, the pause times are in kind of 20 seconds, right? 22 seconds. It is so high pause times. Friend, the second tip that I would like to share when it comes to GC tuning is study the GC causes, right? So where do I find the GC causes? Here, let's go back to this report. In this report, it prints what are the causes. For what reasons the garbage collection is triggering, You get to know. If you don't understand, we can move the cursor here. But what happens is, this tool, based on these reasons, it gives you the tips what to do. Oh, if it's a G1 evacuation pause, then we are saying remove these arguments, increase this XMX size. We give this kind of tips. You can follow these tips. These tips are pretty helpful, right? So study the GC cost, based on that do the GC tuning. So for this shipping company, one of the primary reason why the GC was triggered was system.gc call. This is accounting for 24% of pauses. 24% of pause time is because of this system.gc. Friends, when we were learning Java, we learned this. Oh, system.gc. When you trigger it, it's going to trigger a garbage collection, right? And they also say, oh, it's only a request it is placing to a JVM. JVM doesn't have to honor it, right? You remember what we studied when you're learning Java, friends. But in contrary, whenever you trigger this, JVM always triggers a full garbage collection event. It always triggers a full GC. Think about it. See, I'm at application code. I'm now calling the system.gc. I don't know what's happening underneath the JVM. What if JVM would have just now triggered a GC and cleaned up the memory, and now from my application code, I'm once again triggering the system.gc call. That means what's going to happen? The system.gc, the full GC is going to trigger 2 times. So friends, there's only one legitimate reason why you want to trigger a system.gc. Otherwise, typically, you don't want to trigger system.gc at all. In general, it is a bad practice. From an application, we shouldn't do it. So for this shipping company, yes, it was happening. So how do I disable, if this is happening, how do I go about disabling that system GC? How do I do that? Friends, first thing is, what you want to do, if it's your source code, if it's our source code, I can go to my source code and then I can put a comment that system.gc call, so that JVM will not incur the full GC pause. The second thing, maybe what if this system.gc is triggered from third-party libraries, from frameworks. Friends, here is a secret. I will tell you one more. All those frameworks that we are using, those developers, I don't want to say, they're not that savvy with JVM. They are very good at developing the features, helping us to develop. I have seen a lot of frameworks calling the system.gc. If it is a call by a third-party library, third-party frameworks, how am I going to comment out? That's where we can use this argument. To JVM, you can pass this argument, disable explicit GC. When you pass it, even if the framework or your code calls the system.gc, the JVM will short circuit it. It will not honor it. When he did it, look at this. Started seeing a 3,500% performance improvement. The throughput went high from a 23-second pause time. The pause times became like 89 milliseconds. Okay. Friends, with this, I'm completing the Ryan Smith slides, right? Now I'm going to move on to my slides. Okay. Friends, now the fourth tip I want to share is, try increasing your heap size. Heap size is XMX. Try increasing it or try reducing it, right? That will also have a very positive impact on your JVM. Look, see, this is a case study, it's a real case study of an insurance company. Look, the tool, this is a case study. Look what's happening here. The garbage collection, this is over a 10-day period. Garbage collection is running very aggressively. Look at that full red triangles. A full garbage collection is running very aggressively. Let me zoom in one particular 24-hour period. Okay, look at this. See, at 4:34 a.m., when the traffic is very less, okay, I don't see full GCs that running frequently. But here, look at this. As traffic starts to come, the day starts to begin, the work hours start to begin. Look, the GCs are running continuously. See, friends, when garbage collection run, what does it do? It stops the JVM. If it stops and if it continuously stops, that means the health checks are going to fail. The customer transaction is going to start to timeout. So they were starting to face this pain. It was a homegrown application. So the customers were seeing timeouts. If timeouts are happening, that means your business is losing. So they were in a very severe pain when they were having this. And look at look at the throughput here was 96%. That means for more than 1 hour it is spending on garbage collection. That too it's happening on during the business time. So look what they had was, look at their size. Their heap size was 9.4 GB. Heap and meta space together was 9.4 GB. Now what they did, they increased their XMX size from 9.4 GB. They made it as a 13 gig. They made it bigger. Just one thing they changed, changing the heap size. Once they did, look at the throughput became 99.11%. And now look at this intensity with which the garbage collection is running. It's very less frequently it's running. Whereas if you see in the earlier graph, it was running very frequently. This was one day, it was very aggressively running. Now less frequently it's running. So the timeout problem went away. They started seeing response properly. Friends, I want to share with you one very, very important tip, right? See, now you take your GC log and upload it here. Now, if you don't see any problems at all, or you don't see any problems, long pause, nothing, then don't think don't be happy. Because maybe you might have over allocated your heap size. Even when you over allocated your heap size, then also you're not going to see any problem. If you don't see any problem, then that's a great opportunity to reduce your XMX, reduce your heap size. Friends, when you reduce your heap size, that means what you are doing, where effectively you are saving the cost for your business, for your company. Because say suppose you are running on a 12 GB heap size. Oh, there's no problem. I keep reducing. I make it a 6 GB. That means in that same space I can run 2 JVMs. That means I can dismantle one EC2 instance. That means you're going to cut down 50% of your computing cost, which is phenomenal. Less maintenance, less software license. Right? It is very good. If you don't see any problem, it's a great opportunity. If you see a problem, still it's an opportunity. You can fix it. Am I making sense? Am I connecting with you? Yeah? Okay. Okay, good. So, now let's move to the next tip that I want to share. So, friends, this is the next tip that what I want to share is, you want to changing your heap size. XMX is one thing what you can do. Other thing is you don't have to change your heap size. Sometimes resizing your generation. See, our JVM has young generation and old generation. Resizing your generation will also give you a very positive impact, a very powerful impact. Right? Let's look into. So this is a case study of a major cloud provider. I spoke about this earlier in my yesterday's talk. A very major cloud provider. And we all are, some of us are running our service on this cloud provider. It's a critical service. It's one of the critical service. Look what was going on. So look at this. Yes. Look at their throughput. The throughput is 96%. That means it is also sleeping for 1 hour per day. The JVM is sleeping for 1 hour per day. Now, look at this GC duration, my friends. Here, at 1:43 p.m., this cloud provider critical service is stopping for 14 seconds. Now, another 6 minutes later, once again stopping for 6 minutes, for 14 seconds. 6 minutes later, it's stopping for 14 seconds. And then for another few minutes later, once again stopping for 14 seconds. Think what will happen if your car does this to you. Say I'm driving a car. The car goes for 6 minutes and then it stops in the middle of the road for 14 seconds. I'm keeping my leg in the accelerator pedal, but still car stops in the middle of the road. Friends, but that's what our JVMs are doing. It's not JVMs, all modern programming languages are doing, but except this is a little bit worse case. Our JVMs are probably pausing for few seconds or few milliseconds. So that's what it is. So look at this. They were having, see, the tool gives you a tip. Reduce your young generation size. It gives you a tip. So they look at this. Their setting. They were keeping their young generation size as 14.65 GB and old generation size as 14.65 GB, equally sized. So the tool gives reduce the young generation size. Look what they did when they reduced their young generation size. to 1 GB. So they made the rest of them as the old generation. When they did this, look, the throughput became 99%, and the average pause time becomes 138 milliseconds. Phenomenal, wonderful improvements, right? See friends, first of all, don't be afraid to touch this GC settings, JVM settings at all. It is not at all rocket science, it's basic common sense. Whoever set before you, you didn't also have full knowledge. Because no one has full knowledge on this. Be brave, change it and study. But one very, very important tip I want to share. Try to take your production GC log and do this study, not from your test lab. Because the GC behavior is heavily influenced by production traffic. Enable this setting or take the GC log from a production and take at least a 24-hour period. That is a 24-hour period, so that you can see the high traffic volume and low traffic volume, load it to the tool, and then see what it's doing. It can bring wonderful improvements. Okay. Okay. Now, what is the choice of the choice of the GC algorithm also makes a very important impact on your GC performance. Friends, I told there are 7 GC algorithms. One, the serial GC you don't have to touch because it came in JDK 1, the very first one, so we don't want to use it. Is single threaded. CMS has been basically deprecated from Java 9 and removed from Java 14. Epsilon is basically a no-op GC. So basically, effectively, there's only 4 GC algorithms. Our friend whoever told us the 4 GC algorithms, he was right 100%. I give him applause, actually. So there's only 4 GC algorithms. And then in the Shenandoah is coming from, it's not part of OpenJDK. It was contributed to it was built by Red Hat, and now Amazon is maintaining it. So you would rather go with the one which is part of native OpenJDK. So basically we are left with parallel G1 and ZGC. That's what it is. Friends, I have only 3 minutes to go, but so I wouldn't able to go much detail. But here is flow chart, what you can follow to decide what algorithm you want to choose. Based on the KPIs you can choose. Friends, the next tip I want to share with you is switching the GC algorithm makes a very good impact, right? Look at this. This is from European Union. This is one of your warehouse. One of your warehouse which is used to, it sends in this warehouse sends instruction to robots which does the packaging and shipping, right? Look at the pause time of this application which is sending instruction to robots. What do you see? What is the pause time? 327 seconds. It means 5 minutes it's garbage collecting. I can go, I can have a coffee and come back, still the JVM doing the garbage collection. They were running on a very large heap, 128 gig. They were running on a CMS GC, concurrent mark and sweep GC. It has been deprecated by JVM. So when they switched to G1 GC, look at it dropped, right? Changing the GC algorithm also has a very good impact on your application performance. And friends, once I choose this GC algorithm, here I'm giving you a link of here is that algorithms. Within this algorithm, what are the important settings I want to be looking at? You don't want to go through you don't want to go through all the 600 arguments. Within G1 GC, if you click here, the internet is pretty slow. You can go into the details, and here we have curated and we are telling focus only on these 10 arguments. Just tinker with these 10 arguments, which is good enough. So tweaking within the GC algorithm also plays an effect. Okay, and the next one is sometimes the garbage collection will be impacted when there is a lack of system capacity, when there is not enough CPU cycles, when there is other processes are running and they are eating up the memory, then also the garbage collection will be impacted. You want to make sure your GC is running, when a JVM is running with enough capacity, system resource, right? And friends, the last tip that I want to share is, I told we as a developer, like this gentleman, who is Paul Allen, who is co-founded Microsoft. In his book, this autobiography, he passed away recently because of cancer. But here he talks about in a great length. It is about Microsoft's story. It is very, very fascinating to read. But here he talks about how as a development community we are becoming sloppy. We are not caring about writing memory efficient code. So if we start to write a memory efficient code, then automatically I'm going to create less objects, less garbage. That means less garbage collection time. That means increased response time. So for example, just I'm sharing with you, because in interest of time I wouldn't be able to go, there are some simple tips what do you want to be following when you're writing the code, but in the interest of time I wouldn't be able to go into the details. Okay, so friends, I'm going to share what is garbage, right? I told what is garbage. I told I'll explain what is garbage. So friends, this water bottle, right, I'm having, once I drink water, this one becomes garbage, right? See, I have a pen. Once I write, this ink goes away, this becomes a garbage. So me, I will also become a garbage. Once I die, I become garbage, right? All of you are also going to become garbage at one point in time. So in my opinion, everything is garbage. Everything is garbage. But what we do before we become garbage is what more important, right? Okay. Okay. So with this, I'm concluding my talk. Okay. Thank you, everyone. Okay.